So this is the 42nd video on rigid body kinematics. This is in continuation of the 41st video. Okay. So in this video also I'll take up some problems on the location of IC and also evaluating its locus. Okay. So before going ahead, I would like to repeat that if you go through all the videos, then you don't have to go anywhere else. This is more than sufficient. Okay. And if you have any doubt, you put your doubt in the comment box. I'll clarify it. Okay. So you'll be able to solve most of the problems once you view this video, and and all the videos have been put in the playlist of this kinematics chapter. Okay, so you can access all of them. So I'll write down the problem. So problem is this. This problem is, I like to write the problem. This problem is from Iridov. Okay, I. Iridov. Problems in General Physics by I. Iridov. I'll write down the question. There is a circular disc with center at C. The center C is initially at origin. Center C begins to move along positive x direction and it begins to allow at a constant speed v. Constant speed v. The disk also begins to rotate anti-clockwise at constant angular acceleration beta. Initial angular speed of the disk is 0. Initial angular speed of disk is 0. Two things we have to find. Find the x and y coordinates. X and y coordinates of IC of disk with respect to ground at time t. Okay. And second thing, find the Cartesian equation of locus of IC of disk with respect to ground, G meaning ground. Okay. These two things we have to evaluate. Write up this. Okay. So this problem I will solve by different methods. Okay, fine. This problem will be solved by several different methods. So first what I do, I draw the diagram of the situation. See, this is the positive x-axis, this is the y-axis, this is the origin, this is the disk, its center C is initially at origin, coordinate system is fixed to ground, this is the disk at time 0, center begins to move at a constant speed v along positive x-axis, and it begins to rotate with constant anti-clockwise angular acceleration beta. Initial angular speed of the disk is given to be 0. At time t, we have to determine the coordinates of IC of this disk at time t. So at time t, the disk has come here. At time t, disk has come here. Center has come here. Okay. Center is moving at a constant speed v. This distance is just vt. T time it has acquired some angular velocity omega. Initial angular velocity was 0. Angular acceleration beta is constant. Since initial angular speed is 0 and beta is anti-clockwise, so angular velocity of the disk subsequently will also be in anti-clockwise sense. So omega is equal to beta t. Omega naught plus beta t. Omega naught is 0. Initial angular speed is 0. So omega is equal to just beta t. Alright. Omega is equal to just how much? Beta t. So now we have to determine the IC of this disk. Okay, at t time, coordinates of IC. So this can again be solved with different methods. I first solve with method 1. IC of the disk at time t. IC of disk at time t is at a distance of Vc by omega from C along the direction omega cross Vc. Okay, this type of numerical has been discussed in the previous videos. You'll go there and you'll get all of them. Now I love this one. Okay. Now Vc is what? Omega is anti-clockwise. So omega, since omega is anti-clockwise, this direction is therefore dot, normally out of plane of the board. And since Vc is just V along positive x-axis, this direction is rightward. And direction of omega is outward. And Vc is rightward, omega is outward. From the right hand thumb rule, omega cross Vc is vertically above C. So omega cross Vc is in upward direction, that is along positive y direction. So from the rule of cross product, omega cross Vc is along positive y direction. Is along positive y direction. That is along what? Positive y direction. Okay. So omega is here, Vc is here, omega cross Vc is upward. So IC of disk is at a distance of somewhere here. Here the IC lies. This distance is just equal to Vc by omega. Let the coordinates of IC at time t be x and y. Now you can see x is just this distance, because this is just, this line is normal to Vc. So it's parallel to y-axis. So x coordinate of disk is simply Vt. X coordinate of disk is simply equal to Vt. And y coordinate is Vc by omega. Vc by omega. Vc is simply V. Omega is equal to beta t. So we get the coordinates of IC of disk at time t as x equal to Vt and y equal to V by beta t. So these are the coordinates of IC of the disk at time t. This is the first answer. Answer to first part of the question. Okay. This is the answer to the first part of the question. X equal to Vt, y equal to V by beta t. Now we also have to find the Cartesian equation of locus of IC. That is the relation between x and y. So we have to eliminate t from them. If you multiply these two equations, t cancels out. So if you multiply, we get Vt into V by beta t. That becomes V square by beta. So Cartesian equation of locus of IC of disk with respect to ground is x square equal to xy equal to V square by beta. This is therefore the required answer. Okay, xy is equal to V square by beta. That is therefore the required answer. Okay. Again, it is seen to be a rectangular hyperbola. So this was the method 1. Okay. Now solve this by method 2. I solve this equation by method 2. First method I solved it. Okay. Now I rub this. Now I solve this by method 2. See, as discussed in the second video on rigid body kinematics, which you refer to that playlist, you will get all of them. It was shown that the coordinates of IC of disk vector r is equal to coordinate of some point P of the body plus omega cross Vp by omega square. Here R is the position vector of IC of disk with respect to ground at time t. Rp is the position vector of some material point, some location of the disk with respect to ground at time t. I'll repeat it. R is the position vector of IC of disk. R is the position vector of IC of disk with respect to ground at time t. Rp is the position vector of some location of disk at time t. Now P is some location which is fixed in the disk. So since location of center C of disk is known, so P and C are made to coincide. C is just the point P. Okay. Omega cross Vp. Vp is the velocity of some location of disk, real imaginary location of disk with respect to ground. So in this case P is C. So Vp is just Vc. That is just equal to V. Okay. So now we apply this formula. So R is equal to xi hat plus yj hat. Position vector of IC of disk. Position vector of IC of disk with respect to ground is R vector equal to xi hat plus yj hat, where x and y are the coordinates of IC at time t. Rp is just the position vector of some real imaginary location of disk at time t. Now instead of P we have point C. So Rp is just equal to Vt into I hat. Vt into I hat, okay. And omega we have already known. Omega is the angular velocity of disk at time t. Magnitude of omega is just equal to beta t. And its sense is anti-clockwise. So from right hand thumb rule, direction of omega vector is normally outside. That is just equal to beta t into k hat, where k hat is the unit vector along z axis. So we apply this, substitute these formulas in this. Instead of R we write xi hat plus yj hat. Rp we write Vti hat. Omega vector we write beta t k hat. Vp we write as Vi hat by omega square beta square t square. So this becomes Vti hat. Now one beta t cancels out. So V by beta t, k hat cross I hat becomes j hat. So xi hat plus yj hat is equal to this much. Now comparing the respective coefficients of I hat and j hat on both sides, x coordinate of IC at time t is simply x equal to Vt. And y coordinate of IC at time t is simply y is equal to V by beta t. So we obtained the same answer by method 2 also. And in order to obtain the locus of IC, we simply multiply these two equations. Then t cancels out. So xy is equal to v square by beta. So this is the Cartesian equation of locus of IC of disk with respect to ground. This is the Cartesian equation of locus of IC of disk with respect to ground. Xy is equal to v square by beta. Xy is equal to v square by beta. This is the answer. Okay. So the first question has been fully discussed. I hope it is clear. Alright. Now I rub this one. I'll take up another question. Next question is same as in the previous question with some only difference. Next question, same conditions are same. As in the previous problem, with the only difference that first, center C of disk moves along positive x-axis at constant acceleration a. Starting from rest. And second is the disk rotates anti-clockwise. At a constant angular speed omega. Okay, and then same two things we have to evaluate. First, we have to find the x and y coordinates of IC of disk at time t, and second, we have to find the Cartesian equation of locus of IC of disk with respect to ground at time t. Again, the problem will be solved with two different methods as we did in the previous question. Fine. So now this one I rub it, okay? So again, what I do, I draw the diagram of the situation. So this is the x-axis, this is the y-axis, this is the origin of the coordinate system, this is the circular disk at time 0. Center C coincides with origin O. It is rotating anti-clockwise at constant angular speed omega. Center C is initially at rest. It begins to move along rightward positive x direction at a constant acceleration a with respect to ground. At a constant acceleration a with respect to what? Ground. Okay. Now at t time, the disk has come here. Center of disk is here at time t. This is the disk at time t. Center C is moving rightward at a speed vc, where vc is equal to u plus at. Because acceleration of the disk is constant, center of the disk. Acceleration A of center of disk is constant. So from the formula v equal to u plus at, vc is equal to uc plus at. uc is the initial speed of center, which is 0. vc is just equal to at. Alright. vc is just equal to what? At. And it is rotating at a constant angular speed omega. Again, we will solve this by two different methods. Method 1, M1. IC of disk at time t is at a distance of Vc by omega from C along the direction omega cross Vc. Okay, along the direction omega cross Vc. Fine. So this I rub it, okay. So we apply this concept here. Now omega is in which direction? Omega is this direction, anti-clockwise omega, since anti-clockwise direction outward, right hand thumb rule, and Vc is rightward. Omega cross Vc becomes upward. So omega cross Vc is along positive y direction. So IC of disk at time t will be somewhere here. This direction is perpendicular to the Vc because of the cross product property. Omega cross Vc is normal to Vc. So IC of disk is somewhere here at time t. Coordinates of IC of disk at time t are assumed to be x comma y. So from this we see x coordinate of IC of disk will be this distance. This is the x coordinate. X coordinate of IC of disk at time t is just this x coordinate of center C of disk at time t. But center is moving along positive x axis with constant acceleration a starting from rest. So x is equal to ut plus half at square uct plus half at c square. Half at square. Uc is initial speed of center C of disk. This term goes away. X becomes at square by 2. Okay. And what about y coordinate? So y coordinate is at a distance of Vc by omega from C. So y coordinate is simply Vc by omega. Now Vc is equal to uc plus at is at by omega. Uc is the initial speed of center C of disk, which is 0. 0 plus at by omega. That is simply at by omega. So x coordinate becomes at square by 2 and y coordinate becomes at by omega. Now we have to find this is the answer to first part of the question. The coordinates of IC of disk at time t are x equal to at square by 2 and y is equal to at by omega. These are the x and y coordinates of IC of disk at time t with respect to ground. Now we also have to find out the equation of locus of IC of disk with respect to ground in Cartesian form. For that we have to find the relation between x and y. And if we eliminate t from these two equations, we get the relation between x and y. And that is the locus of IC of disk with respect to ground. So from this equation we see that t is equal to omega y by a. This t I substitute here. A by 2 into t square. Omega square y square by a square. So this becomes omega square y square by 2a. This is the required Cartesian equation of locus of IC of disk with respect to ground. So the required answer is y square omega square by 2a is equal to x, which is therefore the required answer. Y square omega square by 2a is equal to x, and it is therefore the required answer. Alright, fine. So this was solved by first method. Now solve the second method as we did in the previous question. Now we solve this question by method 2. Solve this problem by method 2. Okay. So method 2 is what? Method is similar to the second method of previous question. Let R be the position vector of IC of disk at time t. That is same as position vector of center C of disk at time t plus omega cross Vc by omega square. Okay. Now in this, as we did in the second method 2 of previous question of this video, instead of P we took center C. So here, since center C of disk, coordinate of center C of disk at time t is known, and velocity of disk center C of disk at time t, that is also known. So instead of point P we take point C of the disk. This formula we apply. Now R is the PV of IC of disk with respect to ground at time t. So R will be written as xi hat plus yj hat. RC is just the position vector of center C of disk at time t. Now you can see that position vector of center of disk at time t will be simply displacement of center of disk is along positive x-axis into I hat. Omega is simply omega k hat because anti-clockwise omega direction is outward. Vc is simply at I hat, u plus at formula, by omega square. Okay. So dc is the displacement of center C of disk. Center C is moving along positive x-axis with zero initial speed and a constant acceleration a, and is initially at origin. So dc is simply half at square I hat. 1 omega cancels out. At by omega k hat cross I hat becomes j hat. So this becomes xi hat plus yj hat equal to this much. Now we compare the respective coefficients of I hat and j hat on both sides. If we compare x equal to 80 by 2, 80 square by 2 and y equal to 80 by omega. This is the same x and y coordinates as we obtained in method 1 of this question. So if now to one answer we have already obtained. Again we have to find the Cartesian equation of locus of IC of disk. That is, we have to find the relation between x and y. So we eliminate t from this equation. So t becomes omega y by a. This t I substitute here. A by 2 omega square by a, y square by a square. Omega square y square becomes 2ax. Which is again the required Cartesian equation of locus of IC of disk with respect to ground. It is seen to be the equation of a parabola. Okay. So one more question I have discussed. Alright, fine. I rub this one, okay. I take up one more question on this concept. There is a rigid body whose material point P is initially at origin and at time t its coordinates are t comma t square. The body rotates anti-clockwise at a constant angular speed omega equal to 4 radian per second in anti-clockwise sense. Now we have to find the coordinates of IC of body with respect to ground at time t equal to 3 seconds. This is the required question, okay? So now this will solve by simply with that concept, r equal to rp plus omega cross vp by omega square, as we have been doing in the last two problems of this video. So let r be the position vector of IC of body at time t. Let r be the PV of IC of body at time t. Now we know that r is equal to rp plus omega cross vp by omega square. Now r is the position vector of IC of that body with respect to ground at time t. So r can be written as xi hat plus yj hat, where x and y are the x and y coordinates of IC of the body with respect to ground at time t. That is same as rp. Rp is simply the position vector of point P of the body at time t. But rp coordinates of point P at time t are t comma t square. So rp will be written as ti hat plus t square j hat, plus omega cross Vp. Now omega is equal to 4 radian per second in anti-clockwise sense. Direction of omega becomes 4k hat by omega square becomes 16. Magnitude of omega is 4, so omega square becomes 16 cross Vp. Now Vp is how much? Vp you have to determine. Now Vp is the velocity of point P at time t in ij notation. So that is written as Vpx I hat plus Vpy j hat. Vpx I hat plus Vpy j hat. Vpx becomes dxp by dt I hat plus dyp by dt into j hat. Now dxp by dt becomes what? X and y coordinates of point P at t comma t square. xp is t square. So dxp by dt becomes what? 1 I hat. Yp is t square. So dyp by dt becomes what? 2t j hat. So this becomes I hat plus 2t j hat. This is Vp. Now at t equal to 3 seconds, I'll first calculate it, then I'll substitute the value of t. So this is placed there. xi hat plus yj hat is equal to ti plus t square j. This becomes 1 cancels out. 1 by 4 cancels out. K cross Vp. Vp becomes I hat plus 2t into j hat. Alright. Now I rub this one, okay? So I evaluate this term now. xi hat plus yj hat becomes ti hat plus t square j hat, and k hat plus I hat becomes j hat. J hat by 4, and k hat cross j hat becomes minus I hat, minus 2t by 4 I hat. That is equal to ti hat plus t by 2 I hat. That is same as t by 2 I hat, t square plus 1 by 4 into j hat. This is the xi hat plus yj hat. Now I compare the respective coefficients of I hat and j hat on both sides. So x coordinate of IC at time t is t by 2, and at t equal to 3 by 2 it becomes 3 by 2 meter. One answer is here, and we equate the coefficient of j on both sides. Then y is equal to t square plus 1 by 4, and t is 3 second. 3 square plus 1 by 4, 9 plus 1 by 4, 37 by 4 meter is the required answer. Okay. So this is the required answer. So x coordinate of IC at time t is 3 by 2 meter, and y coordinate of IC at time t is 37 by 4 meter. This is therefore the required answer. Okay. So this video was based on location of IC by this method. Okay. This I fully discussed. Now in next video I'll take 1 or 2 questions, miscellaneous questions on IC, and then I'll take some miscellaneous problems on rigid body kinematics, and then this chapter will be finished. Okay, so you carefully go through all of them. If you have any doubt, you just write in the comment box, I'll clarify it. And if you go through all of them properly, if you understand this, you don't have to go anywhere. You just take up numericals from whichever source you want and you solve it. Okay, so rub it here, fine.